Ready. Okay, here we go. So I am going to talk about the optimization part. So I'm going to work in the class only problems 7 and 8, okay? And then we're going to do some, we're going to share ideas about the cognitive assignment. But I'm going to go over the notes really quick. So optimization basically is we want to find the maximum or minimum of a function, okay? So just for review purposes, what is that we have done in the past to do that? We have found the function, or we are given the function, or we find the function. We find the derivative of that function, and we set it to 0. And that allows us to find any critical numbers. So once we have the critical numbers, then we have two choices. We could use the first derivative test, which is to draw the sign chart to determine if it's a maximum. It's going to be a maximum if before and after the critical number, the derivative changes from positive to negative, that was going to give me a max. Or if the derivative changes from negative to positive, that will give me a local mean. All right. Or I could use that, or I could use the second derivative test. Now, for these word problems, most of the time, the second derivative test is faster than the first derivative test. But again, it's optional and really depends on the type of problem you're working with. The second derivative, if it's negative, then your function is going to be concave down, which implies you have a max. If the second derivative is positive, then the function is concave up, and then we have a minimum. Okay? That's all we need really for tackling the problems that we're going to do. So what is the strategy? The strategy is this. Okay? We assign variables to any quantity or quantities that we need to determine. That's going to be given by the problem. And when possible, try to sketch a graph that will give you an idea what to do. And then second, you write the equation that you need to optimize, or in this case, minimize or maximize in terms of just one variable. It says there in terms of two variables. Sometimes it is in terms of two variables, and you have to put one of the variables in terms of the other. It says find values that are sensible or feasible, meaning if we're dealing with time, well, maybe negative won't make sense. If we're dealing with volume, then maybe negative that will not make sense according to the problem. Okay, so that's what that means. Number 4 says verify that you have a minimum or maximum. Use the first or second derivative test. If the domain is such that that's a closed interval. Remember that you need to check the endpoints, all right, for max or minimums if you are on a closed interval. And that's the strategy, all right? So we're going to start with that. I'm going to start actually with problem 8, and then we go back to problem 7, okay? So let's start with problem 7 then. I'm sorry, 8. We're going to start with 8. In this case, 8 is easier, or because they give me the function. So I don't have to really think about what the function is, just follow the process. So they're telling me that the cost of ordering and storing some product is given by this function. X plus 10,000 over X, right? Now, a delivery delivers at most 200 units per order. Now, that information actually is an interval. Now, we cannot use 0 because if there is no delivery, then we cannot use this, all right? But actually saying that it goes from 0 to 200. 200 is the maximum, okay? So notice, this is not a closed interval, so I don't need to check the endpoints. It's a semi-open interval, so it doesn't apply to us. But I wanted to mention that they're giving you an interval, okay? So it says, find the order size that will minimize the cost. All right, so I need to find the minimum. I'll take the derivative of this function. The derivative of X is 1. Think of this as 10,000 times X to the negative 1. So the derivative of that will be negative 10,000 over X squared. That's the derivative. I need to set that to 0 and solve for x. So from here, 1 is going to be equal to 10,000 over x squared. So therefore, x squared is equal to 10,000. And that means that x is equal to 100. Now notice, from here, you actually will get plus or minus 100. But the negative 100 doesn't make sense for the problem. So this is my critical number. I need to determine if I have a max or a minimum there. All right, I'm going to use the second derivative test. So I'm going to find the second derivative, which will be the derivative of this here. The derivative of 1 is 0. Think of this as negative 10,000 x to the negative 2. So negative 10,000 x to the negative 2. If you were to differentiate that, you bring the exponent down. Negative 2 times negative will be positive 2 times 10,000. That will be 20,000. Right? X to the negative 3, which becomes x cubed in the denominator. Now, if I plug in this value into my second derivative, this is going to be positive because you're going to divide 20,000 into 1,000. That's positive. So since the second derivative is positive, how is my function? Concave what? Up. So that means that I have a minimum. So based on this, therefore, x equals 100 is a mean of the cost function, right?
Wait, Mr. Sanchez?
Yes, sir.
If you were to do this graphically instead of using the math, would that still be a viable way to do it?
It really depends on what they're really asking. Let's say in an IB question, you can support some of your work by showing a graph. Mm-hmm. Okay. You just need to be careful that or mindful that your graph has to be, it has to show the correct information. Okay. Right. So it is a possibility. Mm-hmm. In this case, the problem doesn't say that we can use or not the calculator, so it's kind of an open problem. Okay. Just be mindful of whatever the problem asks and any restriction. So x equals 100 is a minimum of the function. So now you make sure that you answer the question. So you will say something like the order size, that minimizes, I don't know, I didn't spell that correct, minimizes the cost is 100 items or units or whatever. Okay? Mm-hmm. And that's it. That's all you need to do. So this problem, again, is simpler because we are given the function. Okay? Most of the difficulty of this type of problems arise when we have to figure it out. All right, so I'm going to move, unless there is a question, I'm going to move to do problem 7. Okay? So problem 7 says that find the dimensions of an open box with a square base and a surface area of 192 square centimeters that has a maximum volume. So for this one, I'm going to start by actually doing a little sketch. So this is the base of my box. They're telling me that this length and that length are the same because it's a square. And then let me draw the box here. So we have something like this, right? So that's my box, and it's an open box, so there is no top. And we're not given anything with respect of the height of the box, all right? So that's the situation we're given. Now they say that the surface area is 192 centimeters squared. So since this is an open box, and if you were to open that box, then you will get something like this.
Yeah.
Where this is the base, and then you have 4 sides only. Remember, there are no top, right? So the surface area actually is this, the formula for it will be the area of the base, x times x squared, plus 4 times the area of the sides. The area of the sides will be x times what? 8. Okay? So x times h. And that's the formula for the surface area. Now, what is that we need to optimize? The volume. Well, the volume of this box will be x squared, because it's side time, or length times width times height, times the height, right?
Yeah.
So notice, the formulas right now are in terms of 2 variables. I need the one that I need to optimize, I need that one in terms of just 1 variable. So what does it mean? That I'm gonna solve for what, for h here, and replace it in this formula. Okay? So the volume is gonna be x squared times, let's solve for h. We subtract x squared and we divide by 4x. So h is 192 minus x squared over 4x. That is my formula for the volume, right?
Yeah.
Now, that's the one that I need to differentiate, because I need to find the maximum volume. So before I differentiate, I'm going to simplify this, okay? Meaning I'm going to multiply and I'm going to divide by 4x, multiply by x squared, divide by 4x, so I can simplify. If you do that algebra, which I'm not doing just for time's sake, if you simplify this, you should get the following. You should get 48x minus x cubed over 4. That's the volume. Now the volume only depends on what? X. Now, this is what I need to differentiate.
How did you get that?
I'm sorry?
How did you get that?
Well, multiply x squared times 192.
Okay.
And then x squared times x squared. And after that, divide by 4x.
Okay.
That's how you get that. All right, so now.
Mr. Sanchez,
Yes, sir.
do we not multiply the 4x by x squared as well?
No, because the 4x is a denominator. So you multiply x squared over 1 times this.
Oh, okay, I got it.
So you go straightforward. All right, so we're going to find the derivative now. Okay, so the derivative of 48x is just 48. Okay, minus the derivative of this. Well, the derivative of that is 1 over 4 is a constant, right? The derivative of 3x squared, the 3x, I'm sorry, the x cubed is 3x squared.
Yeah.
So that's my derivative. All right. Now I need to set this equal to what? 0. And solve for x. So what are you going to do? Subtract 3/4 x squared from both sides. And after that, multiply by 4, divide by 3, and take the square root. If you do that, x should be 8. Okay? This is my critical number. That's my critical number.
What does CN mean?
I'm sorry?
What does CN mean?
Critical number
What does that mean?
is the value that makes the first derivative 0.
Okay.
Okay, that's a critical number. All right, so now I need to check, is this a max or a minimum? What is it? So I'm going to use the same method that I used in the previous problem. I'm going to find the second derivative. So meaning I'm going to differentiate this, right? Because that's the first derivative. The derivative of 48 is 0. This is a constant, so I'm going to keep it. And I multiply that times the derivative of x squared, which is 2x. So the second derivative reduces to what? 2 over 4 is 1/2, so negative 3/2 of x. And then you plug in the critical number into the second derivative. The second derivative at 8 is going to be 8 times negative 3, negative 24 divided by 2, negative 12. So it is negative. That's what is important. So what does it mean? How is my function? Concave down.
Which means it's a local maximum.
Which means this is a max. So therefore, based on this, therefore, x equals 8, or when, let me put that here, when x equals x, we will have a max volume, right? But the question is asking for the dimensions of the box. That means that we need to use this, x equals 8, and plug them in. Remember, this expression is h, and plug that into h, right? Which is this, in order to find what h is. So you're going to take this value and plug them into h. And if you do the math correctly, which is what? 8 squared, 64, 192 minus 64 divided by 4 times 4 divided by 16. If you do that math correctly, you should get that h is equal to, 4. Okay? So you will answer, therefore, the dimensions of the box are 4 by 4. I'm sorry, 8 by 8, because that's the base, 8 by 8 times 4. That will give you the maximum volume. Okay?
So, Mr. Sanchez,
Yes.
so is it possible when the second derivative is bigger than 0? So how do we answer if it's bigger than 0?
Or if it's bigger than 0, that was the previous example. If it's bigger than 0, then what you have is a minimum. Okay, Ray?
Yeah, but like, how do you write down the final answer? So you just like the first question, right?
Right, so like here, so you said, okay, based on this, because look, you found the critical number, you found the second derivative at that critical number is positive. That's why you know that at these values you have a mean.
Okay, but like when the question asks it's minimum, but when it's actually smaller than 0, so there should be no solution, like vice versa, right?
I don't understand why it's less than 0.
Like when question asks if there's minimum and the second derivative is actually smaller than 0.
Oh, okay. Because I think I understand your question, Ray. Because the second derivative, you're not looking for the value of the second derivative. All you're interested is it positive or negative, the second derivative. Why? Because that tells you the behavior of the function. If the second derivative is positive, the behavior is like this. If the second derivative is negative, the behavior is like that. So if you know that the graph looks like this, it has to be a max. And if you know the graph looks like that, it has to be a minimum. Okay?
Okay.
So you're not concerned on how much it is. You only are concerned about is it positive or negative. Okay?
Got it.
Is there any other question?
I have a question.
Yes, sir.
I understand what we did, but I'm a bit confused about how did you know that what is it called? The x was 8 and the height was 4.
Because
How
I
many
already,
question is that?
Akbar Ali, because I already did the calculations. You see,
Uh-huh.
I don't, one thing that I'm trying to avoid is to do these calculations during this short time that we have. But look, Akbar Ali, you need to solve this.
Mhm.
So how are you gonna solve this? You put this on the other side. So now it's 48 equals 3/4 of x squared. Multiply everything by 4, then divide by 3, and then you get a number equals 64 equals x squared. You just take the square root of that, okay? So I'm asking you to do the math of this piece. I'm asking you to do the math of this piece, and how to find h is because this expression here is h.
Mhm.
How did I get that? From here. Solving for h, okay?
Mhm.
So you need to check on that mathematics, which is the arithmetic. All right, so look, we have 5 minutes left on the class. I wanna use this time, if there is no other question, I wanna use this time to give you ideas of the problems on cognitive, okay? All right, so let's start with this. Let me see. Let's start with this problem, the first problem.
Yeah.
Now, this problem is done exactly the same way that we did example 6 on the notes. Meaning, you find the derivative, just give this point a name, x comma y, or a equals b, okay? And then try to follow the same steps that we did. Well, somebody's saying, or you can take 2, 4, and 6, 3. That's kind of true, okay? However, you are reading the graph, and it might not be accurate. The problem doesn't tell you that it's written as scale, okay? Some of you did that, and in this particular case, it might have been, it might work, but you cannot make that assumption all the time, okay? So you need to label this x, y as we did on example 6, find the derivative of the function, use a general form of the slope, and then do exactly the same steps that we did on example 6, okay? That's what you need to do on that particular problem. Now, this here will help you, because at some point, if you do that correctly, you're gonna end up with this polynomial. They're giving you how to factorize that polynomial, okay? And hopefully you can use this information to do that, all right? On question 2, that is a little bit more complex, because now basically this is like doing this problem twice, okay? So that's why I actually want you to go through the process of doing this like we did on example 6, okay? So I'm gonna explain this problem because you're gonna have to do that process twice. At least I wanna explain this a little bit, all right? So let me redraw this here in my board so I can give you an idea, all right? So look, basically what we have is the following. We have the cosine function that goes like this, like better than that. And then we have the ln function that is doing something like this, right? And they're telling us that there is a tangent line somewhere on the cosine and somewhere here. And you have that line. Hey, I haven't seen Cash. Cash, are you there?
Yeah, I am. Right here, senor.
All right, okay, just making sure that you're not somewhere else. All right, so look, I'm gonna give you the idea, all right? This is what you need to try to do. The question is asking for the slope of that line, right? So, and that's all we have. So I'm gonna name this x equals b, for example. And I'm gonna name this x equals a generic value, right? If this is x and this point is on the cosine function, then this point has coordinates a, comma, cosine of a.
How did you get that?
Did you move the picture?
I just did.
How did you get that?
I just named those points
How did you get cosine A?
because the point is on the cosine function.
Okay.
Okay, this green function is cosine.
Okay, I get
And
you.
the red one is ln.
So it's A, L, N, it's B, ln B.
Correct. So this is b, comma, ln of b,
Okay.
right? Now
Yeah.
you can name it differently if you like, but that's the letters I chose, right? You can name this x1, x2, but whatever makes you happy. All right. So I have now 2 points on that line, correct? Then I could find an expression from the slope. So one possible expression for the slope of the tangent, which is the blue line here, will be the slope formula, y2 minus y1 over x2 minus x1. So this for me is gonna be y2. So this is gonna be ln of b minus cosine of a
Yeah.
over
B minus A.
c minus a. That's just one way for me to try to determine what the slope is.
Yeah.
Okay. All right, so now, how else can I represent the slope of that function? Well, the slope of that function at this point will be the derivative of cosine, isn't it? Because the derivative represents the what? The slope. Does it make sense?
Yeah.
So another way to represent this slope is by taking the derivative of cosine at this point. What's the derivative of cosine?
Negative sign.
Negative sign. So the derivative at this point is negative sine of a, because it's at that point. Right?
Oh yeah. Yeah.
And what about here? How's the derivative there?
Isn't it 1 over X?
Yes, so the derivative there is going to be 1 over what?
X. And they equal each other.
Now this is what you need to do. You need to express this one in terms of just one variable and try to solve that. Meaning these two are equal.
Yeah.
So you solve for one of the variables and then you try to put this in terms of just one variable.
You can solve and then put it in.
That's the strategy for that. So what is this? It's exactly doing twice what you should have done or what you need to do on problem 1. So I'm giving you the idea. You need to try to develop that idea. Okay? Now, let's look at the other problems. All right? Let's look at problem number 3.
Wait, Mr. Sanchez.
Yes, sorry.
Because class is technically over and I have to go to one of the like teacher meeting things. Do you mind if I leave?
Of course, yeah. No, you guys at 1:15, you guys are free to leave. Okay.
All right, cool. Thank you.
You're welcome. Sure. I'm just here for a little bit. Now, for problem number 3, it's basically the same thing. This is the normal. You need to find the equation of that normal. What information is given? The equation. That means that the derivative of this function at this point is the slope of the tangent. You take the negative reciprocal and you have the slope of the normal. The normal is the red line, the tangent is the blue line. So once you have the slope of the normal, you have also this point. You find the equation of this red line. You need to set the equation of that line equal to this point. Meaning what? Meaning that you plug in A into this thing, and that should be equal to B. If you set those two things together, then you're gonna find the coordinates or the value of B. That's the strategy. I know I'm going fast because of time issues, but that is what you need to do.
Okay.
Okay. Now, I'm going to show you question 4 is a little bit more longer, so I'm going to try to give you ideas for 5 and 6 first. Okay. So the way I'm going to do that, on problems 5 and 6, you are allowed to actually use the calculator. Okay. So look, remember, you actually need to do these problems. Okay. So this is it, everybody. You need to use your calculator to find the intersection of the two graphs, the blue one and the red one. Okay. The line there is the normal line. So once you find this point, this intersection point, using your calculator, now what information you have? You have the point, and then you can use either one of the functions to find the derivative at this point, and then use the negative reciprocal to get the slope of the tangent. Once you have the point and the slope, the slope of the normal, you have the equation. How?
Mr. Sanchez.
Yes, sir.
So when we take the derivative of the red line, for example, then in the derivative, do I plug in the x value
yes,
for...
you plug in the x value.
Okay, thank you.
All right. You do plug in the x value. So that's the derivative of the tangent, and then you take the negative reciprocal, that's the slope of the normal, okay? With that information, find the equation of the line. Once you have the equation of the line, how do you find where a line crosses the x-axis? Which of the two variables you make 0?
Y.
The y.
The Y, right?
You made the y. So you made the y equal to 0, you solve. You are probably going to use the calculator for that. Okay? That's the strategy for this particular problem. All right? Let me show you 6. Again, you may use the calculator on this problem. So 5 and 6 are very similar. Okay?
Was the graph wasn't given to us on?
I know it's not given to you, but you're allowed to use the calculator.
Okay.
So you can graph it. Okay?
Okay.
That's why I'm showing you this graph. That is not given to you. You're right on that. All right, so look, this is problem 6. So this is the function. Quite interesting function. All right, so what do they want? Consider that function the normal line to the graph of x at the point x equals 1. So they are giving you this point. At x equals 1, right? So you know the x value. Let me see. Where x is equal to 1 crosses the y-axis at the point 0c. So you're looking for the normal, right? The normal line. So you're looking for this point. So how are you going to do that? You need the equation of this normal and then make what? X equals 0 to find the y-intercept. How are you going to get the equation of the normal? The derivative of the function, plug in 1, find the negative reciprocal of that. That's the slope of the normal. Then, since it's at x equals 1, put 1 into the function, and that will give you the coordinates of the point. Once you have the point and the slope, you can build the equation of the line. Once you have the equation of the line, plug in 0 for x, and you get the y-intercept.
Could you repeat how after we take the reciprocal and then how do we find the points?
Okay, you know the x coordinate, 1, right?
Yeah.
Then plug in 1 into the original function. That will give you the y value.
Okay.
So with that point and that slope, you're going to get the equation of the line. The problem says that don't use decimals, whatever, because they want you to be as accurate. I'm sorry, don't round, because they want you to be as accurate as possible.
Okay.
So try to do that, and that will give you what? The answers to those. It's 1:25. I have office hours at 1:30. The 4 is similar, meaning the strategy is similar, okay? So I'm going to take these 5 minutes to rest a little bit before the office hours. I don't know how many people are going to show up.
Okay, thank you.
I'm going to, listen up, I'm going to put, maybe in Canvas, how to work all the problems from the notes of the last class. So you don't need to submit those problems. I decided not to. I think that these problems are good enough, okay? But I'm going to post that so you can actually see how those problems were solved. So it will give you more ideas how to tackle these problems.
I got 3 of them wrong.
You got 3 of them wrong?
Yeah.
Yeah, I got 4 wrong.
Okay, well, that's why I'm giving you more time to try to work them out, okay?
Wait, so can we resubmit like the ones that we got wrong, or?
I do not know how that cognitive works. I'm gonna stop recording.